Dear students, we are going to look at a very important concept of vector calculus, that is nothing but gradient of a scalar function. It's so simple. If phi is a function of x, y and z, then find the partial derivative of phi with respect to x, find the partial derivative of phi with respect to y, find the partial derivative of that phi with respect to z, multiply that with the vectors I, j and k. Adding all of this becomes a vector, and that vector is called as gradient of phi. In short, we call grade phi. It is also denoted by del phi. So del phi is nothing but dou phi by dou xi plus the same as it is. So if f is the name of the function, del f is gradient of f. Practically it is very useful, because if f equal to 0 is equation of a surface, then del f, whatever vector comes, is, if f equal to 0 is equation of surface. Not only 0, if it is equal to some constant c is equation of surface, then del f is normal to the surface, f is equal to c. Let's quickly have some question. Find the normal, or better we'll go for unit normal. Find the unit normal to the surface, some surface, I'll take it, x square plus yz is equal to 3 at the point 1, 1, 2, I'll take it. Now you can see very easily that this point is satisfying this equation. Similarly, so many other points also may satisfy this particular equation. Whatever points are satisfying this particular equation, they will all make one surface. Back to the point. This point is satisfying because 1 square plus 1 into 2 is 1 plus 2 equal to 3. It is getting satisfied. Now the question is, we have to find the unit normal at this point. So there are two steps. First step is finding the gradient. So let x square plus yz minus 3 equal to 0. That is phi equal to 0. Implies phi value is x square plus yz minus 3. What we need to do first is finding the gradient. Implies del phi, no dot, no cross in between this one. Dot should not be used, cross should not be used. Nothing should be used between del and phi, because del dot is for divergence, del cross is for curl. We will see afterwards. Now just del with the phi. So that is dou phi by dou x with I. Similarly, dou phi by dou y with j, dou phi by dou z with k. And not going into the details of that basic steps, directly I am writing dou phi by dou x, that is nothing but 2x, that comes with y, I, dou phi by dou y. So x square derivative is 0, and with respect to y, z is a constant, so that will come with j, and these are nothing but I, j, k unit vectors. And with respect to z, it will be y, so yk. So this is the vector which is normal vector, del phi. Therefore normal vector is normal vector at a given point. If point is not given, that is a general normal vector. At this point is equal to 2 into 1. I will just substitute x value 1, y value 1 and z value 2 in this one. So I get it as 2i plus 2j plus 1k, that is k. this particular vector is the normal vector. We want, let us call it as some n. Let E be the unit normal vector. E cap be the unit normal vector. You all know that a unit vector can be calculated just by taking the vector and dividing that with the length of that vector. So that is equal to 2i plus 2j plus k divided by the length of that vector. So this divided by under root of I coefficient, whatever I coefficient is there, square of that one. Whatever j coefficient is there, that you have to square it. Whatever k coefficient, that you have to square it. So it is 4 plus 4, 8 plus 1, 9. That is going to become 1 by 3 into 2i plus 2j plus k. This is the unit normal vector. Suppose if there are two surfaces, and at this common point we want the angle between this one. There is a common line of intersection. Now if we take a point P, I'll just better draw a proper surface now. Suppose I have one surface in this way, another surface in this way, and at this common point P, which is the point of intersection of the surface S1 and the surface S2, if we want the angle between S1 and S2 at this P, then what we have to do is we have to calculate N1, that is coming from some surface equation f equal to 0. Here the equation, suppose g equal to 0 is the surface equation for second surface. Then N1 is going to come as del F1 and N2 is the normal vector which can be obtained by just del G. Then if theta is angle between f equal to 0 and g equal to 0, then that nothing but then cos theta is nothing but n1 dot n2 divided by length of n1 vector into length of n2 vector. So I hope you can very easily do this problem. So let's have a short recap. We are talking about gradient of a scalar function. The partial derivatives are calculated and ijk are attached with that one. The resultant vector, whatever comes, that vector is nothing but called as the gradient of that. And in short, GRAD, grade space phi we write it here, gradient phi we write it, or we write it as del phi. And this del phi will give the normal, and if we want the unit normal, we have to divide the normal with the length of that vector, and we can also find the angle between the surfaces using the normals on the surfaces. Thank you.